Good afternoon, everybody. Thank you for coming out. Really excited to be here and to welcome some of the giants of the early years of timber construction here in British Columbia. This is going to be a really special session, and so thank you for making the effort to come out and hear this, almost a trip down memory lane. How do we get to where we are today? And so I'm joined by 10 incredible individuals who have really helped push forward the boundaries of timber construction, not only here in this province, but also around the world. And so my name is Lucas Epp. I'm with Structurecraft, and put together this panel to really kind of explore what created the innovation here in BC and what helped us really kind of, what shoulders are we standing on now as an industry as we look into the future. And so we're going to go through a bit of a timeline of some of the projects that happened during the early years of innovation here in British Columbia, and we're going to tell some stories. So really this session is about storytelling. It's about exploring some of the stories for what went wrong, or what went right? How do we take risk as a design and construction society? And so we're going to explore that through a series of projects, and then we're going to close with a bit of a Q&A session where we're going to open up the floor to all of you, who I'm sure will have a lot of questions, and just think beyond just the projects we're looking at here, but think deeper to what actually creates innovation. That's really one of the things this panel is all about. And so I'm just going to find a clicker here. Is this working? Yeah, so just before I welcome up the panel, just to talk about the history of timber construction here in BC very briefly. Obviously, there's an incredible lineage of using timber here in our province, from places of gathering, places of living, to transportation, right, to monuments that captured the history of our land, to some of the early uses in the 1900s as we're starting to build larger, taller structures with wood, the grain elevators, and bringing plywood here into British Columbia in 1913. And then, of course, we started building larger, taller structures out of timber, brick and timber, the kind of warehouse buildings. This was built in 1907, and it's a 7-story building. We didn't get taller than that for maybe almost 100 years. It took us to build taller than that again. And so also these incredible bridges that connected so many of the societies here in British Columbia, the different towns, the trestle bridges. This was a 600-foot long trestle bridge on Vancouver Island, 150 feet tall, all built with Douglas fir trees, which were really the cornerstone of our timber construction industry. Moving through to kind of codification of timber, the National Building Code, and the start of the Canadian Wood Council in 1959, and glulam coming here to British Columbia in 1962, the first plant with Structurelam in Penticton. And architects starting to explore the use of wood in residential, so Arthur Erickson and Ron Tom exploring the use of kind of timber, large section timber in the West Coast modernism style, and building really beautiful structures, starting to show what timber could do in a modern context as a construction material. We also had incredible innovators working to help build the engineering foundation of what we design today with. And so these two professors at University of British Columbia, Borg Madsen, he helped actually codify how we design with timber as a structural material. And same with Ricardo Foskey, some real innovation. And we started to then see kind of mass timber take its place. I call it mass timber, it's really heavy timber. Glulam arches, of course, the Safeways across North America. And then invention of incredible wood products right here in British Columbia. So in 1986, Macmillan Bloedel invented parallel strand lumber, and then used it at the Expo in over 35 different pavilions. PSL was used across all those pavilions. And then also laminated strand lumber, LSL, also invented here in BC on Annacis Island. And so we go from this kind of history of development of timber as a building product, from sawn lumber, which is just taken directly out of the tree, to these engineered wood products, which really started propelling us beyond some of the structures we had innovated in the past. And so this period, interestingly, between the 1980s and the early 2000s was a period of incredible, kind of an exponential growth of innovation in how we use wood as a construction and architecture and design and engineering society. And so this panel is going to be focused on telling that story between around 1990 and 2010. So it's kind of in that 20-year time span, investigating and going down history lane of some of the projects and the stories that happened. And at the end of that, that session, some of you in this audience may have been at this. This was one of the Wood Design Awards in 2009, and this is Gordon Campbell, our then premier, who's up there with all of the Softwood Lumber Board members from the United States and Canada, and he's got them all wearing Canadian mittens with Canadian flags. Peter Moonen told me this story. And they're all up there and they're chanting, "Wood is good, wood is good," to the whole audience, hundreds and hundreds of people. So this incredible support that we've had as a province from a legislative perspective, from our government, has certainly laid the foundation for creating an incredible kind of ecosystem from which the innovation has sprung. And so I'm very excited to welcome this panel of innovators and designers and engineers and builders to the stage to talk through some of the projects that they've been involved with over this time period. And so because there's so many of us, we're actually going to break it into two sections. So we're going to start with kind of the early years of some of the development of timber, so from about 1990 to about the year 2000. And so I'm going to welcome up to the stage John Patkow, Paul Fast, Gerald Epp, Lubor Trubka, Michael Heaney, and Shinobu Hama to the stage. So why don't you all come on up. And given we have so many, we're not going to do individual introductions, but hopefully these folks need no introduction. And if they do, there's some great posters outside with bios and et cetera for each person. And so just sit maybe in these first, or the middle chairs there. And I'm going to take a seat as well. Hopefully my lapel mic is working. And we're going to kind of jump into this. Come on. So early development. So I'm going to hand it over to Lubor Trubka, who is going to tell the story of one of the earliest uses of PSL, which is a really innovative engineered wood product I just mentioned, invented here in British Columbia.
So thank you very much for inviting and introducing me. But do I have to relive my experience with KGP interrogations, or?
Hopefully not.
Can I stand? And
yeah, I mean, I think we're just going to do it sitting, because otherwise there's a lot of people getting up and down.
Well, all right.
It's okay.
Again, I'm being pushed. So I first experienced BC arriving on a plane as an immigrant in '69. And all what I see, looking from the window, forest, 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 carpets of forest. For me, coming from Central Europe, where wood was exclusive to use only for furniture. And suddenly this was something new. So by the time the plane was landing in Vancouver, I knew that I will have to focus on using the best resource that is available in BC, which is the wood. And I remembered on a very first lecture that delivered by our rector at the university in Prague, he said, as a future architect, you go to site, you look around, what you see around is what you use for the design, nothing else. And so I started up with that conviction. Then the opportunity eventually came with Ice Arena in South Surrey. I was immediately interested. During the interview, they asked me, what kind of arena will you design? And I said, well, arena that has the same feeling of comfort as if you go to a movie, so to theater. I don't want to design arena that's damp, cold, miserable, concrete and steel, place, encouraging only the gladiatorial events on the ice. So it was foolish for me to say, because then they picked me up and they said, well, now you have to give us the ice arena like a theater. So I knew that it will have to be wood. It cannot be in steel and the concrete, because of the dew point on a wood can tolerate much higher humidity before it starts condensate. And so I started up. I'd like to show pointers. I started up. Does it point?
It does point, yes.
Which one?
This one right here.
The little one, okay. I'm sorry. I'm sitting on my cables, and then I can't think without the cables. So I knew it has to be wood, and how do you advance?
This one.
Okay. Doesn't do anything. Disobedient.
No?
This one.
Okay.
Something froze.
Let's try the. Oh, now it's.
Hopefully I didn't freeze.
Right on.
So wood, I thought it should be very simple. Spanning Olympic size arena, 43 meters from column to column. And I thought, design doesn't show on here. Oh yeah, there it is. Just design a couple cranes and suspend in between simple house truss in a triangular form. And the crane has to have, of course, that counterbalance going down to the footings and foundations. Very simple. Unfortunately, at that time, 1989, I had the challenge to find sympathy among the local engineers, and I was told about unbalanced roof loads and from wind and snow and all kinds of earthquake and all kinds of challenges that told me basically, don't complicate your life, just do it like everyone else, the steel and concrete. But I said, I already promised to the city that I will do ice arena like a theater. So I contacted Julius Natterer, Professor Julius Natterer in École de Bois in Switzerland. And he immediately accepted and was very enthusiastic. And once he was on a team, CWMM, John Pell specifically, they became the engineer of record, and we started designing. At that time, Paralam was in existence for a few years, used only by builders, usually as a beam over the garage door, because it has some relatively better improved structural properties. You can see in compression and tension, and it's a little bit better than a glue lamp. On top of it, it was a local Macmillan Bloedel building, Macmillan Bloedel ownership. So Natterer sent us one of his, oops, I don't know, how do we get back?
Let's just keep going.
Yeah.
Yeah.
Sent us one of his students who came and helped us with all the connections. Now I wanted to show the connections, but Jeez, how do you put it back?
There we go.
No, that's, that advanced it. Yes. So the connections were designed by Konrad Merz, who was a graduate student. He came young, single. 1 year later, he left, married, and exported a bride to Switzerland. I wanted to make it a little bit a human story, you know, like a Red Library story. And I had to convince the city of Zurich that it's been done 100 times ago, or many times ago and before, and they are not guinea pigs. And I had to go during the public hearing and say, yes, it's not a guinea pig, and so we better tested everything, and the testing was done by foreign tech laboratories. Again, it's not moving. Nope. I wanted a structure that would be like a spider's web. So there is a spider's web. Very simple, prefabricated, just a few blocks away in Cloverdale, in a warehouse, prefabricated in 2 half arches. So half of the triangular form of the in the middle, and half, and one of the cranes.
We'll need to keep going.
Yeah. Okay. Yeah. So the whole structure was erected by essentially 3 cranes, 4 guys, in 3.5 weeks. Once it was on a site, and luckily, during the time we had a blue sky. You can see there was no Workmen's Compensation Board police on the site yet. No harness, nothing. Yeah. So to supplement the ambience created by the wood structure, we put radiant heat in the concrete slab underneath the seat. And yeah.
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 Thank you, Libor.
And that's it.
It's great.
Thank you.
Now I'm going to pass the mic over to John Packow to talk about one of the very early schools.
Right. So this is the Seabird Island School, as it was known then. It was a very important project for us because of the nature of the client. At the time, this was the first of a series of schools that was sponsored by Maria Del Marceau, who was here for federal government commissioning schools and for native bands. And the Seabird School was a transformation for us in our understanding of the local culture, in that we began by having a tour of an adjacent school that was a conventional concrete block, open web steel joist construction. And we went there with the band to try and understand what they would want in the school. And they were very taken aback by the school. It reminded them so much of the residential schools that we completely changed the development or trajectory of our project and converted to using strictly natural materials that they had historical uses for, with the exception of Paralam, which, like Lubor's project, was a very early instance of the use of that material. But what you're seeing here is a model that we constructed as part of our working drawings, because this was in 1988 that we did this. There were no computers. There was very little three-dimensional representation. And so we were doing a project that had a fair bit of spatial complexity. And so, and the band was building the structure themselves. They were untrained, they were learning how to become carpenters on the site. And so we built the model. A first-year student from University of Calgary built the model, and we sent it to the site as part of the construction documents. If you just move through, Lucas, and you can see these are other views of that model. And you can see there's a real logic to the structure, but it is quite three-dimensional. And one of the things that we were quite dismayed at as the project went forward is that the model actually became a tool for measurement. And so when they couldn't find a dimension on the drawings, they didn't give us a call. They just went and measured the model. The model was built by a first-year student and was only there to represent the general character of the building, not the specifics. Anyway, it's still because of the flexibility of wood construction, the ability to manipulate it. It was almost a chainsaw project on site. Many of the connections were actually developed in space on the construction site. The band became relatively skillful carpenters, and as a result, they took great pride in the project. It was, having built it themselves, it became a really important part of their community and a project of importance for their accomplishment. There has been, in the now almost 40 years of use, there has been no vandalism whatsoever on this school, which is a really remarkable fact. And that's largely because of the fact that it was constructed using their materials by their community and took on a formal language which attempted to respond to their values. And so it was a great success, and it was transformative for us. Thank you.
And so, yeah, John and Paul, just to talk briefly about UBC First Nations Longhouse and
Well, I'm going to start by saying that Lucas sent me an email just before this event today, and he said, well, you're going to talk about Larry McFarlane's Longhouse. And I said, the Longhouse? I've never been in that building, and I've only met Larry maybe once or twice in my life, and I don't really know him. You want me to talk about it? Yeah, well, of course, we were out of communication over the weekend, so I decided to go out to UBC, and I tried to get into the building. It's a private building. It's not publicly accessible, but I managed to get in and met the building manager, who explained to me that this wasn't really possible, but ended up giving me a beautiful tour, giving me a book. And the interesting thing about this, which I think is unbelievably telling, is that 35 years after this building was constructed, there still is a very positive feeling about Larry McFarlane himself and the care that he took and the engagement process, which they still feel is probably the most successful engagement process that has been undertaken in their experience. So I was really completely overwhelmed by the gratitude that they had and the care that Larry obviously invested in designing this building. I think it's a remarkable accomplishment, and I don't know whether Larry's here tonight, or this afternoon, but he deserves a great deal of respect for having accomplished this.
Yeah, I would just add. Yeah, I would just add on to that we supported Larry in a lot of his early work, including this Kispio school here up north of Smithers in the Hazelton area there, and also Penellicut School over on Cooper Island, and other projects at North Caribou Community College. And he really has to be given credit to being one of the pioneers of, call it, maybe not contemporary timber design, but quasi-contemporary timber design, or sort of in between the old and the new. And he bridged that gap, and he was a wonderful collaborator, and he had a love for wood and for logs as well.
Yeah.
And so, yeah, just some very distinct architecture that he put out there in the early 90s.
Great, thank you. Now we're going to talk through District of North Van's Municipal Hall.
Yeah, so it's mostly a concrete building and some steel there too, surrounding this atrium area here. And I just want to point out here, it's really too bad that Peter Busby can't be here today. Apparently he's traveling and he couldn't make it. But Peter's one of those, he had the vision for, he always had a vision for exposed architectural structure. He wanted to show the structure as part of his architecture. And of course, we loved it as structural engineers, and we've had years of wonderful collaboration. But then in the early 90s, mid-90s, he also caught a vision for sustainable building materials, and that wood could enter the conversation again, the design conversation, where it had been neglected for so many years. And this was one of the first expressions of this atrium roof, which is a two-way roof with a underbelly of steel tension rods and steel castings. And the crisscrossing beams up the top of the compression struts are actually Paralam. And that was our first foray actually into something that was, unusual contemporary timber design. And we had to learn a few lessons here too. That joint that you see, the crisscross cruciform joint, those are pairs of twinned Paralam beams, and there's a cruciform steel plate that connects them, and we just put in 4 bolts, I think, at each connection side. And it felt a bit spongy up there when I walked the roof, and that was because the holes where we didn't realize you should actually epoxy the bolts into the hole, or use pin connections as we use nowadays, right, for a good solid stiff moment connection. But lots of lessons learned in those early years, and you as the audience and many young engineers, you can be the beneficiary of a lot of the mistakes that we made, or the oversights, or whatever you like to call it. But that was one of the first examples of contemporary modern timber design using Paralam.
Mm. Yeah.
Okay, I'm going to take over now. And being Paul's partner for many years. We were getting challenged by architects, including with timber, how to advance the use of timber in our structures. And there was this British high-tech movement going on prior to this that we learned of, and we just thought we'd get on the plane and head over to Europe and have a look. And that trip was quite seminal in our careers and in how we began to understand the bigger picture of architecture and structure. And we saw, when we went over there, the fruit of the high-tech movement. Not there yet, son. But it just confirmed to us the importance of creating beautiful structure. And so Paul and I came back quite invigorated. And in the preparation for that trip, I'll tell a little bit of story about how Structurecraft got started. I did some history research, and do this, you young aspiring architects, engineers, and builders. Research history. Look what's been done before, and there's a lot of lessons to be learned there too. And I became intrigued with Brunel and Eiffel and Stevenson and these early builder engineers that took all kinds of risk. And it was that was kind of seminal in, as I say, in my mind, in starting to think about, could we bring this builder engineer type of thinking to this world of timber construction. And so on that trip, we happened to, I just went through some old slides. They're probably not the best slides, but this was in Professor Naderer, who Lubo referred to in Lausanne. And they were doing all kinds of testing with timber concrete composite back, in the 80s and 90s, long before anything like that was thought of over here. And so, and move to the next slide, he was also doing these shell structures in timber. And so these were, quite motivational for us to see this on a world scale. And inspiring for us. It was very, very important. So the Vancouver Aquarium, I don't know, Michael, maybe you want to.
Sure, I can start, but Shinobu and Jerry are going to be, it's going to be a bit of an improv exercise here, so they can interrupt me and chime in. Part of the discussion for the three of us was to give a bit of a tribute to Bing Tom, who's a was a very multi-dimensional character and had some very broad interests and endless curiosity. But one of the things I wanted to talk about a little bit is talk a little bit about sort of the delivery side of timber structures. And it may seem odd to start with this image of the Chan Center, which is not a timber structure, although there's lots of wood finishes. But when I joined Bing in the sort of late 80s, the vast majority of the work we were doing was on our own account. And he had this kind of holistic view. He really felt that traditional architecture was much too siloed, much too independent. He really wanted to be involved in everything. And he was doing that with his own projects. But as we started to get more kind of legitimate commissions, he wanted to bring that attitude in. And the Chan Center was a challenged project in terms of a lot of real budget issues. But there were two really unusual pieces in the building. One of them was this acoustic canopy, which was this multi-ton canopy that had to move up and down over the stage. And we knew that we would be hung out to dry by the general contractors who'd never seen anything like that before. And so he was not afraid of risk. He took these two, this piece and another piece in the building, and said, "Look, we will design it and deliver it for the budget." And that's what we did. And we were able to, that had a huge impact. And that kind of designer-built, design-build attitude was instrumental in when we started to do, when we were introduced to Jerry and started to do more heavy timber work. So the first opportunity, we kind of went into it not as planned as you might say, but it was a little addition to the Vancouver Aquarium. It was actually enclosing an outdoor pool. It was the pavilion, it was called the Pacific Canada Pavilion. It was themed on the local aquatic life around here. And one of the things we learned was it was an incredibly corrosive environment. It was a saltwater pool. You couldn't use steel, or at least regular steel, in any effective way. And because of the Pacific theme, we gravitated, and with Jerry's encouragement, we gravitated towards wood. Around the same time that we were doing this, Bing had taken up sailing in his mid-50s, and he bought this beautiful old wood boat. And I think the sort of aesthetic of stainless steel and wood was very instrumental in terms of driving the structure and the architecture. So we had these long spans over this saltwater pool, and in order to minimize the depth, we ended up with these hybrid trusses of stainless steel and wood. Here's a great picture of Jerry and Bing. So Shinobu, my colleague here, he and Jerry, they spent ages detailing the heck out of these trusses in particular, but they're also even the window struts were supported by Paralam. And we thought we had really thought everything through, and the prices came in, and they were just out of this world. Like, it was totally off the budget. And Jerry, to his credit, said, "You know what? It's not that complicated. I'll build it myself." And so it's not very often you get your structural engineer who'll say, "I'll build it for the budget." And so that was in my mind anyway, the creation story of what ultimately became Structurecraft. And so Structurecraft, I think you learned tremendous lessons on this as well, but it was born, and we delivered this.
Learned what it was like to become a contractor. And the risk associated with that, and making it all fit together.
That's right. We had a very complex skylight because we wanted to naturally light the pool. So there was this careful geometry to make sure the sunlight hit the pool. And I know bringing that together at the last minute had a few glicks.
So also this project, the first time that we started using the Paralam, and so this was an opportunity to learn the material. And I think at that time, the maximum span was 60 feet or 80 feet, right?
60, yeah.
Yeah, correct. And our budget was $450,000.
That's right.
All included.
He had to live it, yeah. That's right.
So roof structure and also the grazing support. So that was quite challenging.
Mm-hmm.
yeah, so we took that contract on, and really it was the fruition of, as I say, of previous years of thinking about this, and then we had, as I say, we had no idea, you know, the responsibility of delivering a quality product for a price, and that's the life I've lived ever since. But it gets more comfortable, but I can tell you there was very many sleepless nights on this one. We didn't have deep pockets at the time.
And Jerry, wasn't the original contractor's price correct?
Probably.
Yeah. Became a loss leader.
Beautiful project.
But it was a launching point, right, for Structurecraft.
Well, I remember the stainless steel guy telling me, I'd been talking to him for weeks and learning all about stainless and the number 4 polished finish that we were going to use and all the, you know, curiosities about stainless and learning it all just, and then he says to me, he says, sorry, I can't do it for you. and I was completely dependent upon him. I had a pricing from it and everything. He says, I've never done business with you before. And how good is your credit? And he basically was about to shut me down, and I was in panic mode because we had no time. So anyway, one of those interesting learnings.
Then Paul, over to you to...
Yeah, so materials testing facility, maybe you just want to bring it up there, Lucas, and this building was affectionately referred to as the building that was constructed with garbage. Anybody will want to guess why? Because it used like 90% of the structure was constructed using recycled lumber. There was a City of Vancouver warehouse on the site right nearby, and so they had some long span trusses in there and some wood columns and some glulam purlins and a whole bunch of wood decking. And so our task or our mandate was from Peter the architect here, can we build this all with the wood that's available on site? So we did. And the 2 main lessons to learn here is maybe just back up for 1 second. To that one there. There was a splice right in the middle of the span of that long span truss. That truss actually went originally right to the right and left-hand extreme of this building here. That's how long it was. So we actually put these V-supports underneath, and one of the reasons for that was that try and make that splice at the middle of the bottom cord work with today's code, and it was impossible. We would have had to add, I don't know how many more bolts. And this thing stood up for 70, 80 years under slightly different load conditions, but nevertheless, it was considered a safe design. And now we find ourselves having to just add so much more connection material that, times have changed. That was one discovery on that. And the other thing that was sort of interesting here was we had way too many glue lams. And so this became the first GLT floor. Because we took the glue lams, we just turned them on the side by side, didn't even put a plywood diaphragm over top of it, and just exposed them, polished them, and that became our GLT floor. So that was sort of a interesting experience, constructing the building out of garbage, as we called it. So it was a fun one.
Yeah, the Glen Eagles Community Center was an interesting project. It was, for us, the first project in which we really sort of worked in a collaborative way with the engineering team, with structural and mechanical. And there were innovations from our point of view in both regard. First of all, it's a very hybrid building with tilt-up walls, cast-in-place floors, and then a heavy timber roof. And the interesting thing is that it was our first experience with off-site construction. This roof was fabricated into panels, courtesy of Jerry's insight into how things can be made effectively. And Jerry, you're welcome to jump in and talk about that. But for us, it was a revelation because the roof went up in days, and it was there. I think there was even a membrane on the panels that just had to be seamed, and so that was quite amazing. And the other part was the tilt-up and cast-in-place concrete was all radiant. And imagine doing tilt-up and having radiant within it and connecting all those panels into a continuous system. It became the first radiantly heated and cooled structure in North America. And the courtesy of Vladimir Mikler at the time, who was a very creative guy, is a very, very creative guy, just actually worked with Vladimir and Paul both on a competition earlier in the year. So the old guys are still going.
Still kicking.
Still kicking, and also a tremendous credibility in this project as a result of David Schoen's contribution. He was the project architect in our office and really was meticulous in getting the best quality execution that we could imagine. All in all, it was a project that was surprisingly sort of fluid and easy because of the way in which the team was working together, and has been a very successful project in the community for ever since it's been constructed.
Amazing.
Nice site.
Okay, now we're going to move on to Surrey Central City and talk through some of the timber structures on that project.
Sure, I'll start again. But so this was a massive kind of 1 million square foot project, but it the sort of the catalyst to get it going was a new university for British Columbia, and it was it was initially meant to be the called Tech BC, which was the Technical University of BC. It was established in the kind of mid-90s as an idea, and it was to do two things. One is to serve the population south of the Fraser, which was not well served by post-secondary education, and the second was to start to generate tech workers, because the 90s was the first sort of tech boom. And without getting into the details of the project, one of the things that Bing really wanted to do was, it was obviously the thought was a tech university, it should be sort of high tech, but how could you do high tech in a way that reflects British Columbia? And of course, we were working with Jerry on the aquarium around now, and so the decision was made to have a series of heavy timber components. We ended up having 3 big heavy timber components, and we were able to, again, to carve these out of the project. Jerry, who was our lead structural engineer in the project, actually resigned from his commission there so he could take on these 3 components without any conflict of interest, and then we embarked on them. This is one of the ones which is referred to as the Galleria. The building itself is complicated in that about half of the university was suspended on top of an old regional shopping center, which was part of this idea of trying to intensify Surrey City Centre to get a downtown going. And one of the challenges we were told, if you just go back to the last slide just for a second, was we were told that we couldn't close the mall for a single day during construction. And so Jerry came up with this idea, well, what if we can sink a series of columns and then hang the structure over that to allow the mall to continue operation? And so the shape of the building is actually determined where the empty stores were in the shopping center. So that's why we ended up with this curved shape.
Michael, it started even earlier than that with this idea. This is Bing. Mm-hmm. We're going to span the whole length of the mall. At first, with a 600-foot long, 3-story high truss that formed the classrooms. That was the early idea, and then this was a more reasonable approach to penciling in these cruciform-shaped shear wall sections wherever we could inside amongst the tenants.
Right. So we ended up with this roof shape, and you can go on to the next ones, which was this sort of fish-shaped or lozenge-shaped roof. And one of the things I learned from you, hopefully it's true, is that by taking on a design-build role, that you actually had way more design time, thinking time, than when you were acting as the building structural engineer. And so that was incredibly valuable for our team, people like Shinobu and others on the team, to be able to spend time and refine the idea and to drill down, to control the cost, to make sure that it was really beautiful. In this case, a lot of times Shinobu was instrumental in this, integrating all the services, so all the sprinkler pipes could be integrated into these trusses and things like that. So one of the huge values of this approach is is being able to spend more time thinking, to refine it, to make it better, to make it cost effective, to make sure that it can be delivered properly. And that was, for me, it was a real eye-opener in terms of the value to a project you get when you deliver it this way through this sort of design-build process. So this, you know, and one of the things we learned from Jerry is he said it's all about the connections. And if you can minimize the number of connections and just repeat those connections over and over and over again, so you can control the costs the best. We had the luxury of more time to refine these ideas and these dimensions. So this is at the very bottom of those trusses.
Yeah, if you go back a couple of slides
yeah.
to the so the previous slide. Yeah. So a whole bunch of these trusses, and they all have different geometries. And that casting, going back forward again, is at where the cables come down, and they all have to meet at different angles depending on the truss. So we developed what we called a trumpet casting, and we studied the geometry in all the different cases, and we actually were able to find one connection that one size fits all for all the different geometries of the trajectories of these cables.
So these sort of ductile cast iron casting connections became a real theme for all of the different.
So that trip in 1994, one big part of that was the learnings about the castings, and we saw the Pompidou Center, the huge castings done there, and that just started to pop in our minds. Could we use castings for our work with timber? And so here you see the mold for the castings that came at the end of those struts that join in with that trumpet casting. And the next slide shows the geometry of these cables as they come into the wood in a three-dimensional truss. And so what we did is we made the trusses into doubles. And we actually made the trusses so that there's a cord on each side, 20 feet apart, but then those pairs, those trusses come together with a 4-inch gap between them. And there you see it. And so each of those cords had to receive that cable at a different angle. So we had to figure out how to drill those holes that were up to 4 feet long, depending on the geometry that we had to deal with. And so all these things were part of the engineer having to actually build it. And now you've got to learn all these things.
Mm-hmm. So there's the trumpet casting in place. And so the whole thing was I guess, prefabricated, brought to site, and they were sort of stored on the roof of the shopping center.
All the pieces were pre-made in just a kit of parts form, and then assembled on top of the roof, the existing parkade. And we used that as a working station to assemble these up to 90 feet long, 20 foot wide, 30 foot tall trusses.
So there were all these trusses under tarps for a long time, and all of a sudden they were all dropped into place, and the roof was there. Like it seemed like in about a week and a half, it all just appeared. This wonderful roof with the shopping center continuing to operate underneath while we were building all this on top, and then finally the magic day came when they cut open the roof and exposed the structure above. And so this is the final build out. So you can see the existing shopping mall below with its kind of 1980s style paving and stuff, but the new structure on top with the whole life of the university animating the space. So the second of the heavy timber components is what we called I think we called it the mezzanine roof, or was it? Atrium roof. Atrium. And this was because of the geometry, a space frame seemed to be the sensible way of approaching it.
It was free form in plan,
That's right.
And how could we approximate the edges of a free form in plan? And the support conditions were quite spotty, or quite predicted. We had to precisely prepare ahead which columns we were going to use to support that truss. And so the edge of that space truss is actually created and concealed by that plaster ceiling from the underside, but it projects out we'll see more pictures of it. But it's a peeler core space truss. The peeler cores are the byproduct of the plywood industry. They're the core that's left over when they've peeled the layers for the plywood. And so it's a very inexpensive waste product, and could we use this for...
I think I heard at the time you could buy them for $4 each. But they had to be obviously graded and looked at after that. But
yeah, and so this is coming back to Ricardo Foschi we talked about earlier. And here we see those ribbons on there. So we had to come up with a casting that would receive all these 9 members into a node. And those ribbons have to do with the force that's in that, and the type of force, compression or tension that's in that member. So each of them had to have a different connection type. And so we had to monitor that on site, and those ribbons were all about the engineer being able to go out on site and actually determine that that was the right member being installed in the right place. Thousands of these members. And here we are testing it, and Ricardo helped me on this because we had to, we didn't want ugly connections, and so we wanted to put lag screws in end grain, which the code frowns upon. And so we did testing, and we created a whole histogram of test results. There you see actually a steel band that's inserted around the group of lag screws, glued into the end of the end grain to control checking and splitting of the wood. And we did testing of both without and with. And he helped me greatly by making it a statistical means of getting these forces under control and manageable in the type of connections that we could actually achieve with that. Here we are from the roof above looking down on, and we made these struts coming down from below to make a universal connection to come in to that casting. As I said, there were only so many columns we could put in there.
And then the third component was with the facade system, or the entrance into the complex. These are some sections that Shinobu drew early on, and these timber columns were holding up a concrete roof, which sort of blew people's minds. They weren't used to sort of seeing it in that context at the time, anyway, and we were using them to provide both the sort of lateral support for the window system as well as supporting the roof, and really for the finish, so that they were doing sort of three jobs in one. And again, we called these, I think, the elephant foot castings for the base of the columns. And didn't you built the largest lathe in British Columbia to turn those columns?
Yeah, we had to actually develop our own lathe in order to take on this project. And it was really a converted portable sawmill that we got a millwright to help us with. This is a picture of where the columns go up and these arms come out to support the facade. And as you can imagine, the glazing planes, this is a free form in plan, and it's tilted at 4 degrees. And so the geometry is absolutely critical. Because there's stainless steel cables which hang those connection points and support the glazing, which is fastened to an extrusion in the face of those parallam muntins. And so that last slide was how we used the cables to create the geometry for the glass. We knew the fixed point on top, we know the fixed point on the bottom, we put tension in the cable, and then we brought all these members to that joint, and then we had aluminum plates that were knifed in between them that were blank, that weren't drilled, and we drilled holes. Once we got the geometry right, we drilled a hole and we pushed those pins inside the because there's like 6 pins in each of those ends of those members.
Yeah, and so then, I think Arena Stage in Washington, D.C. was, another exhibition of some of the similar design concepts.
Exactly. It was kind of the next generation, which we, and again, this was the first time heavy timber had been used in Washington, D.C. Washington, D.C. is an incredibly, we think Vancouver's bad for approvals. Washington, D.C. takes it to another extreme. And I have to have a shout out to our code engineer, in this case, the late Glenn Gibson, and he was able to educate this incredibly complex bureaucracy and get the approvals to allow us to do this. We had to make all kinds of code changes to get this through. It was a time when one of the many times Canada's had strained relations with the United States over softwood lumber, and so it was very symbolic that we were able to bring this wood building into DC at a time when the Americans weren't keen on our wood. And of course, here's a picture of Bing. In this case, instead of the elephant foot casting, this is a different shape. Bing used to refer to as sort of a ballet dancer coming down on point. So these columns are even fatter, even wider than the ones we had at Central City, and they come down in this very elegant.
These are up to 60 feet tall, carrying a roof that was 500 foot long, a steel roof. And it's all supported off these columns around the perimeter.
Great. Well, and so we'll keep going here. To make up some time, just maybe we'll quickly talk through this project.
Yeah, this project is really to show it was a remote project on the west coast of Vancouver Island, and so we decided we wanted to incorporate everything inside these roof panels. So let's go to the next slide. Next slide, yeah. So in the shop here, so these are like 35, 40-foot span elements, and we didn't want big trusses, so we are actually using the plywood as a stress skin, about 3 or 4 layers of 3/8 plywood, and then we incorporated all the services and the lighting cables, the acoustical treatment, the thermal insulation, the batten ceiling, and the sprinkler piping were all incorporated into these panels in the shop, and then shipped to site. And then they even had a roofing membrane on them that was just welded together at the joints when we erected the panels.
Great, and so I think that concludes our first part of looking at some of the early years and some of the early timber projects. So now I'm going to ask for a little bit of change of seating, and going to ask for Martin Nielsen, Michael Green, Eric Karsh, and Shelley Craig to come up to the stage. So thank you everyone. So now we're going to talk about kind of the next phase as timber started to scale up here in BC, the use of engineered wood and really taking it to a new level, both in terms of size and particularly in terms of height, and also in terms of the types of structures that we used timber in. You saw a lot of residential or civic or projects in the last phase, and so now we're going to start talking about use of timber and other types of buildings. So Martin and Paul, over to you.
Yeah, very happy to be here, and this was a kind of seminal project for myself. I had the privilege of working with Peter Busby for 15 years, 96 to 2012. He was a visionary, a maverick, you knew him well, who took risks and was always pushing. This was a project that I was the lead for. It was Busby and Associates at the time. And we were awarded the 2 stations on the Millennium Line in 1998. It was completed in 2002, 2002, which was remarkable that it happened that fast. Very large project. I think the story with all of Peter's work was really the relationship with Paul Fast. Paul Fast was considered a part of the design team and was early, in the studio early on for every project that we did, and that was a really kind of endemic thing about Peter's work. If we go to the next slide, what was remarkable was that this was a project, the Millennium Line was delivered by the province. It was a provincial authority, and they learned the lessons from the Expo Line. The Expo Line is a brutalist kind of, if you can't afford to buy a car, you would ride the Expo Line. It was a pretty sad statement in 1986. So this was the first major transit project after Expo Line. And it was all about the passenger experience and prioritizing the passenger experience and trying to entice people to get out of their cars and take transit. The transit was cool and the stations were beautiful and they were safe and comfortable. And the concept here, this was the only station that was over the highway. The concept was to kind of create this protective cocoon, right, that sheltered people from the elements, be it sun, wind, rain, the noise of the street below. The image that's on the screen, if you can just go back one. No, sorry, one more. Forward, sorry. There we go. The shape of the building was actually, and the media called it a spaceship that had kind of landed from somewhere. But it was actually a canoe that Peter had hanging in the office. It was a handcrafted antique canoe that had these series of ribs that would have had a piece of canvas kind of stretched around them. And that was the inspiration for this. So in plan, it was a curved plan, and it was a curved section that kind of compressed. And it's just a series of ribs that were inspired by this canoe. This was probably the most important image, drawing in our construction set. This is we started using MicroStation. So Peter bought one MicroStation software license. We had one person trained on it, and we never used MicroStation again. But it was the only way we can reconcile this incredibly complex shape. And you have to realize that the platform itself was sloped at 0.5% for drainage and other reasons. So you didn't have a datum to work off. So these are all the coordinates. It's the coordinate at the bottom of the rib and at the end of the rib, which defines the entire station. So, and it worked really well. And this section that you see, we've kind of overlaid the construction drawing with the image. And if you want to talk about the nail lamb assembly and the ribs themselves.
Let's talk about the ribs first, because that had an interesting genesis. There was a vision right from the get-go to incorporate timber into transit station design. That hadn't been done for decades and decades. I can't recall any that have been built in the last 80 to 100 years prior to this line being built that used timber. There may be some that I'm not aware of. However, that was a vision. The champion for all this here was Alan Hart, architect, who worked for RTPO, the Transit Project Office. And he departed us, I think he left us about just under 2 years ago now. Mm-hmm. But he fought the good fight to get permission to incorporate timber into transit stations. So he has to be considered one of the pioneers, because there's hardly a transit station that we design now, we're involved in a lot of them, that doesn't have timber in the platform roofs.
It was a very radical idea at the time. And it was because it was provincial authority. And they said, well, we're going to do it.
Yeah. So that was successful. Then in terms of the ribs here, the question was, well, do we make them wood, steel, concrete? My original proposal actually was, let's put wood at the top there, but where it has to take that sharp radius turn down towards the supporting beam, I'd originally proposed concrete there, and Peter felt quite strongly, and your team there, Martin, that should be a steel haunch. And so we were glad to oblige. So we make it a steel haunch, so we didn't have to have the layup with very thin laminations coming around that corner for the glulam beam. And the other reason was too that from a vandalism point of view, they were concerned that if that was wood there and there was access to that wood, that people would, pedestrians would carve their I love yous into the wood. And
it was called the hockey stick rule. That no wood could be within 3 meters of the platform, because anybody with a hockey stick, that was the reach, the 3 meter.
Yeah, right.
Alan would have come up with that, I guess.
Yeah. And fortunately, we had a fabricator that was willing to assemble steel with wood. That was George Third and Company. And they're another one of the pioneers of the wood industry, even though they're steel fabricators.
Yes.
And in fact, the fact that they did this project here positioned them well to be the successful bidder, and actually the only bidder, gave them the confidence to bid on the Olympic oval arches, which were way, way bigger than this here in terms of scale. And they took a lot of heat, actually, from their fellow fabricators with the accusation that they were abetting the wood industry by taking wood into their steel shop, into their blacksmith shop, and basically assembling wood and steel. So, you know, kudos to George Third and Company and Rob Third there. Like, they deserve a lot of credit for this. Last thing to point out here would be the that wood laminated roof on top there. It's basically a nail lamp roof. That came out of my experience in 1997. I spent half a year in Germany, and I realized, you know, they're starting to begin to incorporate what they call over there Brettstappeldecke, or like basic nail laminated panels. They're starting to put those into buildings. In fact, they put it into the Canadian ambassador's residence in Berlin. And we had a crack at that job, and we proposed, well, why don't you, instead of solid wood, which they proposed, the engineer and contractor proposed, why don't you put TGIs in, much more resource efficient? And they said, no way, you know, then they basically didn't hire us, and they put in the solid wood deck. And that sort of stuck in my brain. And then coming back here, this project came up, and originally we had glulam purlins running longitudinally and metal deck over that. And then the thought, why don't we just put simple 2x4s, span them like 5 meters in this case here, and just nail them together, and it's like simple as all get out. And so we proposed that, and we got mega pushback from the quantity surveyor because they thought this is too much labor, so unusual, yeah, and they just weren't used to it. But compare that with glulams and steel deck and all the connections and that, it's actually a no-brainer. And so they went and built it. We managed to persuade them. We did our own costing. And so this is the labor cost that's going to be involved here. And this is the cost of lumber. Put a skin of plywood on it. And anyways, the rest is history. It got built. And it still looks like $1 million today. In fact, they just redid the roof on there. Did you know that?
I know, they ruined it.
Actually, they put some insulation on top now.
No, but the anchors, the roof anchors have now been bolted right through. Oh. And yeah, don't go.
Okay.
But I love this image where you can see the layup. And it literally we were inspired by our Yaletown studio, which was nail laminated floors, right? Yeah. So old school idea.
Yeah, it's really a throwback to 100 years ago, how they did things back then. Except for sort of contemporarizing it now with...
this was pine beetle kill as well. And we had a hard time sourcing enough, but the pine beetle issue was kind of at its forefront at that point. So we spec'd pine beetle.
Yeah.
A much simpler station, the little brother or whatever to Brentwood was Gilmore, and it was not in the middle of a highway. It didn't have that problem, but the site was really, really poor soils. It was a bog, basically, a peat bog. And it was also slated for development on either side of the station, so it would be completely closed in. So we thought simple, light, a light structure, and something elegant. This is a sketch from Adam Slavinsky way back when, and it shows this kind of playful, billowy, almost these roof panels that were dancing. We didn't know how to actually do this yet, but it was a beautiful idea. And I guess if you go to the next slide, we've got Structurecraft steps in.
Yeah, well, so we came up with this concept here of this LSL panel, which was 2.5 meters wide and 5 meters long, and we'd pre-curve it, and then we used these steel cast struts again with some cables going to each corner. We thought before we actually build this, like 64 panels, we better build a prototype. So at the Structurecraft shop, we built a prototype with turnbuckles and everything in there you see on the right side, and just a very crude one. And we learned from that because when we put the tension on there, the ends of the panels were actually bowing up a little bit. So we had to put a little bit of a steel stiffener along the edge of the panel in the final design. And we dispensed of the turnbuckles because we figured out a way to pre-tension it without that. Yeah, there you see the panel.
And that was Paul Fast hanging from the bottom of that cord, so that's commitment.
Oh, that's the old school version of load testing, you know?
Yes.
But it turned out great. It was very disciplined design, very simple, 64 panels, repeat panels, and it's still up there today looking nice.
Still looks great.
Yeah.
Yeah, amazing. So Eric, over to you to talk through NVIT.
Right, so I started my career in Ottawa, and in 1993, a friend of mine came out here, told me about FastNet and said, you got to call these guys, they're looking for you as an employee right now. So I called and ended up traveling across the country to come and work for FastNet. I was employee number 6 at the time, if you remember. And I actually worked on the Kispioc School with Larry and the Penelakut with Shelley and Jennifer. And then we decided to found Equilibrium in 1998. And very shortly after that, we get a call late at night from Peter Busby. And he says, can you handle a 50,000 square foot college building? And there's only one good answer to that question. So, and then we felt the pressure that you referred to from Peter. He's definitely a very persistent visionary. So it's a native college, and it was inspired by the Kukwili, which you see here, which is the First Nations dwelling that is typically used in the interior of BC. And as you can see in the section here, this is very much like a passive building that we would consider today. It's naturally ventilated. It's buried in the ground, so you get the tempering from the ground in the winter. It keeps you warm. In the summer, it keeps you cool. It's got a green roof. So this is the idea that inspired the building, not only structurally, architecturally, but also mechanically. So the building is circular. The plan was actually to complete the circle over time. The center of the building is an open atrium that acts as a chimney. And initially, because it's a First Nations project, there was a cultural incentive, of course, to use wood. So we started with an all-wood structural concept. And that was, it was a provincially funded building, very, very tight budget. We realized fairly quickly that we couldn't afford to do the whole thing in wood. And we also had aspirations to do a passive building, which requires thermal mass. So Peter said, you know, it's a circular shape. We can build a flat plate in concrete. We get our thermal mass. It's a lot easier to form the curves. And actually that was following a statement that I made that timber is most efficient in compression. So he said, how can we use the wood? And I said, well, it's very efficient in compression. We could use it for the columns to support the concrete. And we had just met with Hans Windiger at the airport with Mark Rufians from Structurland. And Mark Rufians for us was our way into the construction side of design, because he was always open to innovation. And so he agreed to buy a K2. And this was the first project that was actually produced on a CNC in Canada. There were 256 columns, 2 sizes, one 300 in diameter at the bottom floor and then 250 at the top, and supporting flat plate concrete. And we took the approach to form the concrete first and then insert the columns afterwards. And as you can see here, we used castings, which meant to represent the tip of an arrow in a stylistic way. And then later on, you see the columns coming to site. They were sized just right to be installed by hand. And with 3 guys, these columns were installed in 20 minutes. So they were lifted in place, bolted into the slab above, and lifted just right, and then grouted at both ends in 20 minutes. So there's a view of the building from the outside, which is all clad in Alaskan yellow cedar. Sorry, I'm looking at the big image. So that's a view of the library with the columns. The previous slide shows the library without the columns, and then with the columns. And finally, a view of the atrium with some of the concrete-bearing columns, and then some of the columns that form the atrium, which cantilevers past the concrete slab.
Cool. So was it one of the first projects that used timber columns to support a concrete slab?
As far as I know, it was the only one, and I also lost sleep over those. The idea of putting concrete on timber was so foreign, you know, naturally speaking, as a concept. And so we had the opportunity. We had good friends in Europe, whom I consider to this day to be the grandfathers of modern timber engineering, Julius Natterer and Michael Flach, who worked with him in the early days. So I had the opportunity to pass the idea by them, and Michael said the column doesn't know that it's supporting concrete. A load is a load. And same thing with Julius. We were having a beer in Whistler at the World Conference on Timber Engineering, and he had exactly the same reaction. It says, why not? And so that gave me some comfort, and I mean, it went really, really well. So,
cool.
Nice.
So then on to Prince George Airport.
Yeah, so this is a project that I did with my previous partner, Steve McFarland, and it's 2 different phases we did. And for context, I had done a lot of airports. I think at this point I'd probably designed 15 international airports, and they were all steel. And the most recent before doing Prince George was Ottawa Airport, which is my hometown. I grew up in Ottawa. And when I was designing it, I wanted to do the entire terminal in wood. And my engineers were Arab out of New York, and they had no idea how to do a big wood airport, which is funny now because we see a lot of wood airports. But at the time, it was very hard to do. And the memory I have is presenting this idea of doing a wood to the Ottawa board of directors, and they said, "Oh, you just want wood because you're from British Columbia." And I said, "No, I'm from Ottawa, and before Ottawa was our nation's capital, it was a timber town, right? It's the logging in the Ottawa River was really what started Ottawa." And so it's funny how now there's been a huge shift on airports, but for me it was this airport, Prince George, with Steve, that allowed us to kind of explore it. And it was 2 phases. The first phase was a new addition to the building, and the second, which is actually the image you see here, was an addition to a steel building. And so we decided to kind of marry wood with steel in that addition piece, and then do all wood in other areas. And certainly this was, it came from a nod to some of the projects you've already seen that were so influential when I moved to British Columbia and looking at wood. And so there was a lot of appreciation we had in getting to work with Eric and in sort of learning about what we thought were really elegant details. If we jump forward a couple slides here, I'm going to move pretty quickly through this project to leave time for talks. But as you can see, it was sort of 2 phases. But what probably was the most unique aspect for us on the project was this was the beginning of working with CNCs, working with Eric. That elliptical shape is the way we formed the columns for the building. And then we did develop a casting. We actually built this in my basement shop at the time in North Van. And the casting was holding the roof of the building that allowed us to create this sort of delicate floating of the roof above the main beams. But in order to pay for these castings, we had to drive the cost down by buying a lot of them. And we realized we just needed to figure out every possible place we could put one of these castings. So if you go back, or go to the next image, actually, we ended up with not only these castings holding the whole roof system, but also holding this really unique point-fixed glazing system off those elliptical columns, allowing us to create this glazing system where the point fix doesn't go through to the outside, so it was completely thermally broken, and the first time that had been done. But otherwise, a fairly straightforward wood project, and mostly the elliptical, the ability to work in CNC was really interesting. But also sort of, for me, important because it sort of informed the way I thought about wood products, which was actually, interestingly enough, to use them in their most basic state and not to overly shape them. So although we shaped them here, we sort of moved away philosophically from doing that when we moved to later projects. So,
I'll add something if I can. The year before we did this project together, I did a project with Shelley actually in Soto, which is a small First Nation village in northern British Columbia. And Shelley and Jennifer had the idea of doing a canopy that represented a feather, which was part of the typical totem. The crow was a typical totem animal for this band. And so there was the concept of doing a beam that represented the quill of the feather, and that beam, of course, wanted to be shaped. And Structurelam had just purchased their 5-axis CNC, but the shape that Shelley and Jennifer came up with meant that we were going to shave the beam across the glue lines. And back then, clear glue lamp didn't exist in North America. So we convinced Structurelam to certify themselves to glue with clear glue so that we could shape that one beam in the canopy. And that's the experiment that led to the idea of shaping those columns here. And that first glue lam up north was the first clear glue lam in North America, as well as the first CNC shaped glue lam in North America. And then we used it at a larger scale in the airport.
Yeah, it's really beautiful, that difference. I'd actually forgotten that story, that how important that was. The expression of those curved shapes would not be what it was had it not been clear glue. And it shows that evolutionary process of how important it is to kind of focus on every aspect of the timber when you're thinking about it. And so that was a good learning lesson.
Okay, now we're going to cover the Olympic speed skating oval in Richmond.
Yeah, I'll just lead off, and there's Jerry and I could talk for 2 hours about this project and regale you with all manner of stories, and maybe I'll just take you to the very end of it and remind you of a quote that something that Larry Pedora, the project architect, said to me in private. He said, Paul, it was all finished and completed. He says, Paul, the Richmond Oval was an experiment that went terribly right. And that sort of sums up this project. And it reminds us too, and I think you can maybe gather from the panelists, for those young engineers and architects that are sitting here today, that you have to, if you want to pioneer, if you want to push new solutions, push the boundaries, push the envelope, call it what you like, you have to have an appetite for risk, and you also have to have the stomach for risk. Because there's times, like Jerry mentioned too, the sleepless nights, on whatever project you mentioned before there, there's sleepless nights, and this one had a lot of sleepless nights, both Jerry and myself. And, but winding it back to the very beginning, this was a project that we wanted really, really badly. Like when the Olympics were announced, this was going to be the only signature building, new building that was going to be built, and we wanted it really badly. And I would drive by here on Number 2 Road Bridge, past the site every day, coming home from work, and just saying, oh, are we going to get this or not? And in order to try and get it, there's a little bit of storytelling. I actually rang up Peter Busby and says, Peter, you're going to go after this year too, right? Let's hook up with the architect that designed the Lilyhammer Oval, and let's go visit that oval there, and let's go visit a couple other ovals, Salt Lake City Oval, and then we can step forward, put a proposal in, and perhaps get this commission. And of course, I was hoping that we might be on multiple teams too, but I went and traveled there with Peter. And we learned a couple of valuable things there in Lilyhammer, and this is one of the valuable, the value of, like Jerry said before, what has been done in history, what's been done in the past. And there's two things that I discovered in that trip, and that was number one, in the Lilyhammer Oval, like exposed air ducts there, the air ventilation ducts, are the bane of beautiful architecture. They're hanging there right in space in the middle of nowhere, and it was just like, it was not very nice. And the second thing we learned is that they had, not on that one, but on the skating rink in Lilyhammer, actually the oval was in Hammer and the skating rink was in Lilyhammer. In Lilyhammer, the skating rink there, they had prefabricated panels, this massive roof structure, and they went with a prefabricated solution, dropped them in one after the other, and we thought, that's the ticket for a big roof. So armed with those ideas, we were successful in getting the project with Canon Design then, and launched into it and designed charrette. And as it turned out, what was a real, I'd like to consider a real blessing of this project is that, both Jerry and I had a chance to participate with critical contributions in the design of this building here. Typically, in our practice, we always, I would run a project or he'd run a project. Sometimes if we ran into trouble, we'd bounce things off each other. But in general, we just sort of ran our own teams. But in this case here, we both have an opportunity to do a major contribution. And Jerry will talk about the panels right away, where that went. The major arches there, to get rid of this mechanical ducting issue, just being exposed, we said, well, let's just create hollow arches and bury these ducts inside the arch. So it became a V-shaped arch. If you can just scroll ahead a little bit there, there's the concept. Can't get into detail on all the other factors behind that concept, but there it is then, like glue lamp sides, and we decided instead of a wood bull nose in the bottom to connect everything, we'd go with a steel section there, and it was connected at the top of those glue lamp sides with some steel bracing and another steel wide flange beam, which rises off the top of the arches at the end because we want to lift up, create a higher facade, better view of the North Shore Mountains looking north there. And so we lifted those beams up off the the steel beams off the wood beams as we progressed northward. And the ducts are all buried inside. So everything was out of sight and out of mind. And if you just scroll ahead, yeah, and maybe into that fabrication shop. Yeah, this one here. You can just see the size of that fabricator there next to this, this is just a portion of the arch. I think this is two 25-meter sections put together just as a trial run. And as I mentioned before, in this case here, Rob Third and his team, they were willing to step forward and bring huge volumes of glulam into their, call it blacksmith shop. I don't think since the history, in the whole history of the world, has there ever been this much wood in a steel fabrication shop. It's just massive amounts. And they took heat from the union, from other steel fabricators for abetting the wood industry here. But, and they were the only bidder that was left standing, which was very interesting. There was 3 or 4 to start with, and the other ones all headed for the woodwork, and Rob put in a price. And he and his team did a fantastic job of building these massive arches and erecting them. And then the original concept also was like some sort of prefabricated wood 2x4 panel that would rest in between. We put a proposal forward for that, which was not the final proposal that Jerry developed, and got the call one day from the architect saying the panel is dead because we don't know what the fire rating of it is, we don't know what the acoustic rating of it is, and we don't know who's going to build it and if the costs will hold. And so just forget that and just put wood purlins across there and a metal deck and call it a day. And that would have just sucked the life out of this project here. And so I went to Jerry and I said, Jerry, can we do something in Structurecraft? Should we give him a design build proposal? And take it away, Jerry.
Well, we knew that the province wanted to showcase the use of wood, especially with the pine beetle kill thing going on in our province, and to show that there's nothing wrong with this wood. So, could we create a structure that would span over 14 meters, 43 feet, I think, 44 feet between these arches using just ordinary 2x4s. And so what we did was we created, and plus the acoustic problem, and you need to contain the absorbing material in behind the wood. And so could we create a vaulted space inside? And so we created a shell structure out of 2x4s that were nailed together and shaped in the shape. The architect wanted this heron feather look, so there had to be 3-dimensionality between the arches. So each of those are like a heron feather that cascades and reaches out to the north. And so there you see it's both the thermal insulation and the acoustic insulation incorporated inside the section that's made out of simple 2x4s. And so, well, that started a whole cascade and so we took this on on a fixed price. And we incorporated, we built the panels, incorporated, again, the services into the panels in the shop with the acoustic and thermal insulation already incorporated. And so these panels effectively created really quite a nice acoustical space inside this enormous room. That's the structural action that's going on. We did all kinds of testing. Obviously, we're not just simply nailing these 2x4s. We did nail them initially, and we created a whole CNC process, custom CNC process, to put together these assemblies of boards, and a whole process. And we had a strict time limit. It's called the Olympics that's coming. And so we created, how many of these panels? 550 of them, I think. 12 feet by 45-foot panels. In a shell, and then here we are testing the shear connections, because you can imagine these 2x4s, they're creating this thrusting action to the top chord, and so we had to shear connect them with ordinary steel angles, light gauge angles, and here we are in the shop testing these panels because they're completely unique, if you can imagine. So yeah, we actually saw the structural engineer's nightmare called snap-through buckling in one of our tests, and we changed our design. It was a simple change in the screw that connected the steel angle between the 2x4s that made all the difference. It's a long story, but what you saw there was scientific research in progress, at risk. There's the sprinkler pipes inside. And of course, aesthetics, right? And we engineers, we want to. We were trained, as we said, we were trained to try to assist and become part of the design process to create excellence in the built work.
So Lucas, when they dropped in that last panel, do you remember that occasion, Jerry? The last panel, the missing tooth at the end of the building, and they had a big ceremony. The Premier Gordon Campbell came out, and they began chanting that mantra again, wood is good, wood is good. He had the whole crowd just hyped up there, And there's poor Rob Third, having to take this all in and ready to crawl underneath his pickup truck, and get out of sight. Because he was the one that put so much of this together here, these mega arches, made them into hybrid wood steel arches. And I think hybrid is good is maybe better than wood is good, you don't want to force wood. But
well, the nice thing about it was that the sprinkler guys could take the sprinkler lines that ran on top of the arches and quick connect them without having to do any lifts from the floor below. Like all the kinds of construction and mess was happening on the floor below. We could handle a lot of the construction from above. So it saved a lot of time and cost in this prefabrication effort.
Yeah, and all the electrical conduits were buried inside that arch. You can imagine you're splicing the arch into 4 sections too, so everything's got to be spliced as you go along up there too. And it was a major coordination effort, but everybody was on board, and the experiment went very well.
You remember that time we showed up on site together and the first arch had gone up and we said, what have we done? It was so skinny. It looked so skinny.
Yeah, but the problem was they had all the media out for the first arch erection. They had all the media come out, and they had the two 25-meter arch segments, coming off the sides, off the concrete buttresses, and they're going to hang a spliced 50-meter segment in here. So they lifted it up. All the flags were hanging, the Canada flag, the BC flag from the arch, and everything, and they're dropping it in place, and they're jigging around. They spent an hour like putzing around there trying to get this thing to fit, and it never fit. And eventually the media and the politicians got bored and they just drifted away, and then the pieces was taken out and brought to the bottom and said, we got to figure out what's going on here now. As it turned out, the scaffold towers weren't set at the correct erection elevation, and so that's why it wasn't fitting into place. So, but that's the type of stuff that gives you heartburn and it doesn't let you sleep so well at night. And then, of course, as Murphy's Law would kick in as usual, we thought we might get this all done in the summertime during nice weather. And then we hit the winter time, we had gushing rainstorms, and those arches filled with water. And even though we had a drain hole at the end of the arch, it got filled with construction debris. It got blocked. And so it was like a bathtub full of water at the end of the arch. Of course, the wood is just getting soaked, and you're thinking, oh, this is going to check like crazy later on. And anyhow, those type of experiences, it did check. You can go out there, you can actually see some checking there. But fortunately, we had drilled rods, epoxied rods, into the ends of the glue lamps from top down to the middle and from the bottom up the middle to control any checking that may happen where the wood can't shrink because it's also getting hung up at that end plate by friction against the connector plate. So
certainly a seminal project. All right, well, now we're going to move on to Shelley and tell a little bit of the story of the rise of light frame and mid-rise in timber.
Thanks, Lucas. Just a little bit of context. I really started my career when I was a Beatty architect, newly registered with Henry Hawthorne, and worked as the project architect on the Shadbolt Center. It was a joint venture with Hotzenbacher, and what did I learn? I learned about collaboration, and really learned through this process, C.Y. Lowe was the engineer, of really the importance of the team working together, you know, of Henry Hawthorne working closely with Hotzenbacher, all of us getting, you know, informed all the time by CY as to, you know, how to really work in an innovative way and how one could, in a non-combustible building, by looking at the roof as one area. And I think many of the projects we've looked at that are really seminal started with the roof, and how do you create a beautiful roof? So fast forward from there and really taking the roots, and many years later, first of all, and projects come back. So we actually got a chance to revisit the Chabot Center as Urban Arts Architecture, the practice that Jennifer Marshall and I founded in 2006, and we returned to do a feasibility study and look to expand some of the lessons learned at the Chabot Center. It's now a different project being done as a design build, but it was really great to kind of have that loop back and work with many of the same people that we had worked with many years before. 2006, Jennifer and I decided that the world was ready for a women-led architecture firm. And so we joined up. We've been doing a lot of collaboration, just the two of us together. And then we're doing this sort of think. We have to find some work, who's going to hire us, talk to former clients. So we called up Oscar Farrow, who was working with the Canadian Wood Council at times, said, hey, you know, what are you up to, this and that. And he said, well, I have a project for you. And we said, oh, okay, well, what's that? And he said, well, why can't you build higher than 4 stories in wood construction? And we said, well, it's because that's what the building code says. He said, that's not an answer. I want you to do a research project and find out how we can do this. And so Jennifer and I talked to each other. It's like, well, we don't do this. Like, we're not code consultants. Like, what do we know? We can't do this. And Jennifer says to me, I can't say no. You have to say no, because apparently, like, I was the tough cop. So apparently I couldn't say no either, because the next thing Jennifer knew, there was a purchase order coming across the screen from the Canadian Wood Council saying, we want you to do this study, which is expanding market demand for Canadian wood products. And it's really, how can we build higher in wood? And it seems like such a long time ago, and it seems incredibly sort of obvious to all of us now. But at this time, 2006, 2007, you can only build up to 4 stories in BC in wood construction. So what did we do? We did, and we learned from the Chabot Center way back when. We consulted our friends. We phoned up Eric at Equilibrium. We talked to him and Robert. We talked to Jeff Triggs, who's code consultant at the time. We formed a little group. We then basically had a series of different forums, both here and in Toronto, to basically gather input from code consultants, from engineers, from architects, from authorities having jurisdictions to figure out what were the roadblocks, how can we do this. Research different products that they were using in Europe at the time, and found this thing called CLT. And basically thought, oh, this is really interesting. Maybe we can start to use this heavy timber equivalent. This will help us with the pursuit of building higher in wood. So to cut a long story short, we finished our report. Our report ended up on Gordon Campbell's desk, who seems to be a big name in the history of innovation in wood. He turned to the building safeties branch and said, why aren't we doing this? They hired GHL, Andrew Harmsworth, and within a year, the building code was changed from 4 stories to up to 6 stories in wood construction, starting with residential use. Next slide, please. So along the way, one of the things that Jennifer and I did, again, it's very much kind of, okay, let's play, let's test out these materials, how do we learn? So we'd been asked to design an entry to an exhibit that was actually at Harbourfront in Toronto, and we said, okay, well, we're gonna do a CLT pavilion. It's like, well, there isn't any CLT in BC, in Canada at this time. So Lynn Embry-Williams, who's a VP at Canfor at that time, basically worked it out, worked with a contractor she'd worked with before, and helped us produce some CLT panels, which we then worked with the mill worker, and he's like, ho, he's French. And Philippe, he said, I can do this, it's just like IKEA on steroids, no problem. And so he basically helped us to design this little tiny pavilion that you see, and then it ended up being the first CLT building in structure in all of Canada, and really the rest is history. And so really setting the scenes allowed for so much innovation, so much incredible work. And it's really important to start to step back and say, how can one contribute, not necessarily through an individual building, but how can we start to make systemic change. And much of the work that we've done was then taken up in spades by Michael, Eric, others to really push it further and look at how we can build higher and better in wood.
Yeah, it was a seminal moment. I think that Change to 6 Stories really resonated across all of North America. Yeah, Martin and Paul, maybe to quickly chat through SIRS over at UBC.
Yeah, this is another project with Peter. This was now we had become Busby, Perkins, Will at that time, and then ultimately became Perkins Will, but this was kind of mid-stroke. The Center for Interactive Research on Sustainability was the vision of Dr. John Robinson. He was a climate change researcher at UBC. He's now a poet, not a poet laureate. He's a Nobel laureate for his work with the IPCC. And he had this vision for using the building stock as research. UBC is a research institution, and he thought, well, we're not getting information out of our actual building stock. So he had this idea for a living lab that was a research entity in terms of social, economic, environmental sustainability, and the idea to push it forward. This is another collaboration with Paul. As Peter told John Robinson that it had to be a wood building because wood is the only building material made by the sun, and that kind of stuck, and it set. If we go to the next slide, it had very ambitious agenda in terms of environmental performance. It was LEED Platinum. Living building, it harvested sunlight, it collected rainwater and used it within the building, it had geo-exchange, it took waste energy from an adjacent building and reused it in the SIRS building and sent the excess back to the building that wasted it in the first place. So it was doing a lot, but it also had to be mass timber. If we go to the next slide, we get this is a 4-story interconnected atrium. The entire building is mass timber, except for a little bit of concrete here and there. So we had a code issue in terms of how do you, first of all, wood, but also interconnected space, right, in terms of exiting. And it was a fully integrated project. In fact, UBC had made a research project out of the design process as well. So they were following and documenting that. And at one of those sessions, and it was LMDG at the time, who was our code consultant, we were talking about the rainwater collection. And he said, so wait a minute, I think it was Frank Mattia from LMDG. He said, so wait a minute, you're collecting water, you're storing it in the building. Is there any way I can tap into that with a fire pump and use it to charge the sprinklers in case something happens and the sprinkler system doesn't work or it doesn't respond fast enough? He said, yeah, of course. And that changed everything in terms of allowing this amount of wood and the interconnected floors and the laboratory use as well. We're now doing that as a kind of a regular way of, or accepted way, right? The on-site cistern is an accepted way now of dealing with those code issues. The next slide is the lecture theater. It's a 450-seat lecture theater. You see a concrete beam going into the slide or into the page. And then these curved glulam beams. And there's actually a roof garden on top. And the curved beams created this beautiful kind of mounded space that was part of the outdoor landscape. You can also see the wood deck. We went back to nail laminated timber again, kind of old school. And so these were prefabricated, nailed off-site, fabricated. The contractor took on that scope. And in this case, the wood panels were just lowered on top of the ribs, and there was enough flexibility that they just took the form of those curved ribs, and it worked out beautifully. The other thing that we did from a code perspective was we had a wood exit stair. And the exit stair, the two exit stairs at the back of the building are some of the most beautiful spaces in the building, and it's quite remarkable to go into an exit stair that you expect it to be concrete and the smell of urine. It's actually a lovely kind of enveloping space. We had 10-meter clear spans. You can see the wood deck here. There were 3-meter grid spacings, and it's a building that I'm personally very proud of. I've been lecturing on this building since it was built. I do a couple of lectures every year and a tour, and the students, we go through the building and open up all the back spaces, and that's been going on for, I don't know, 12 years now, so.
Cool. Yeah. Maybe just a short comment, by the way, we've heard the name LMDG a lot here as a co-consultant, just so we don't forget Andrew Harmsworth. Are you here, Andrew? And Andrew is responsible for like pushing the wood industry forward here in this province. Like, he's an engineer's engineer, an architect's engineer. You don't get any better. He's a can-do engineer, and he's just done amazing work on the code front to facilitate wood construction. But yeah, the only other comment on this one here is if you, on that elevation that you showed there before, Luke, the very first one, there's also, this is an example of a moment frame building actually, because in the long direction of the building, you see those long dark bands? In behind there, between the vertical columns, which are wide columns, you could almost call them wallums because they're not long enough to be a wall, but not short enough to be a column. So you call them wallums. In between there are plywood, or wood stud plywood skin panels that just fit in there and basically create a moment frame in the longitudinal direction of the building. So that was sort of a fun pioneering effort in this one here, which we've never actually done again since then.
The big disaster that we still suffer from, I mean, I don't know why, after everything that you've seen, all the experience locally, we can't keep buildings dry during construction. This building got soaked. They had to pull up all the plywood, had to refinish. And that was a fair amount of time ago, and we're still having those problems to this day. Can we solve that?
We're getting better, Martin.
Yeah, okay.
Getting better.
Right, Michael and Eric, over to you for North Van City Hall.
Yeah, it's funny. There's for those of you visiting, there's the city of North Van and there's the district of North Van, and both city halls are in this today's presentation. Peter Busby did the district one. So this is the city of North Van, and the project was on the right hand in the image. That was a public library, and then on the left was the existing city hall. And we decided to expand, or the city decided to expand into the library. But we needed to bridge the two with an atrium space and then redo the library itself. Eric figured out that we could save the 2-story concrete building, which seismically didn't meet the code, by fiber wrapping the concrete columns. And then we decided everything else, of course, would be wood. And our goal was to find a way to build this central atrium space with with timber in a way that would allow us to sit on the existing foundations and sit on top of the existing building as effectively as possible. This is before CLT existed in North America. Eric and I had my old partner Steve and Eric's old partner Robert all went to visit Austria and learned a lot about CLT years before this, but we really wanted to use CLT, but this was around 2008 we were designing it, and we didn't have it available, and so we decided we would use LSL, in part laminated strand lumber, in part because I really loved what had been done on the Gilmore Station project, which was LSL. And the span is about 9 meters wide, and we were working in an imperial building because it's an older building, and so we decided to panelize the roof structure here. What you're looking at is not a ceiling, it's actually the structure, and the way we designed it, and Eric's going to jump in here, is in these basically flat trusses where we had a solid piece across the top of laminated strand lumber, and then strips going 90 degrees to that at the sides and the middle. And then on the bottom, these strips, 18-inch wide strips with 6-inch gaps that allowed us to create this really slim sandwich of a panel that had inside of that fabricated acoustic panels and a gap that would allow us to run all our services through it. And by doing that, we could build it off-site. We could place it fairly quickly. Go back one more, though, for a second. Structurecraft ended up building this. It's hard. it's really hard sometimes to do something that is out of the norm from a structural point of view. There was, this was quite unusual from most builders' point of view, and Structurecraft sort of raised their hand and said they could do it for us, which is incredible. We feel really grateful for those that are brave enough to take on these new projects, and you've seen already tonight the kinds of projects that they were able to produce with us. But what was interesting about this is Eric, and you should jump in, came up with the idea of how these materials could be screwed together, screwed and glued together to create this sandwich. And one of the things I remember is our mechanical engineer saying, ultimately we had to run a sprinkler system down the length of this system while we were building it. And the consultant said that can't be done. And so we just picked up the phone and called the sprinkler manufacturer, said, yeah, no problem at all. And it was a reminder of engaging trades in the process early if you want to do things. And ever since, we keep sprinkler parts in our office because we're so inclined to make sure things fit, make sure things are very thoughtful in order to get these very thin structures to work. And we learned a lot in the way this worked. The bottom box there is actually a cantilever, and so the next slide shows that, and Eric should speak to this, this is the HPV system that was the first, I believe, hybrid wood concrete structure using this sort of embedded mesh. You want to speak to it?
Yeah, it was a test case for us for a wood concrete composite floor. It's a very small area. It's what, 300 square feet, maybe 400 square feet.
A bit bigger maybe, but yeah.
Yeah. Anyway, so we reached out to the fellow who invented HPV in Germany and worked with them to develop this floor system, a very shallow glulam beam floor system using the HPV system to connect to the concrete topping and then creating a T-shaped system. It was more for the interest of trying it out. The roof panels you can think of as a custom-made hollowed out CLT panel, because we had to run services through it and develop an acoustic absorption mechanism. We basically looked at developing the interstitial shear that we needed between the top and bottom layer with just a few strips of wood. But it works as a CLT essentially.
Can you go back a few slides to that interior atrium shot? What we wanted was a structural solution that hit all those surfaces. You can see there's no lights in that even. At the end of the cantilever there were lights, but our goal typically was to really understand how we could just integrate things and make them invisible in the process, so even the sprinkler heads barely show up in the system. This project was really informative for ultimately creating our work with tall wood. And tall wood was actually happening while we were designing this, the exercise I'll talk about in a minute, to create the tall wood book we did. Because we were trying to, again, understand how to build these large panel-based systems. And because we didn't have CLT and we had to use LSL, we started referring to the products as mass timber at that time, which wasn't really the nomenclature at the time. And so it really became the beginning of this now global vernacular of speaking about these products as a family of mass timber. And one of the stories that I will always remember about this project is we had a really hard time convincing the LSL manufacturers, and I know there were earlier LSL projects, so somehow they had convinced to use big panels. Typically this material is cut into small pieces to be used in light wood frame construction. And we wanted these big pieces. They're 64 feet long and 5'9" wide, if I remember correctly, or something. 8 feet. Or 8 feet, these ones were. And we wanted to use these big pieces, and the manufacturers, at least the two big ones, Louisiana Pacific and Weyerhaeuser at the time, didn't want to give us these panels. But what happened is we were doing this around 2008 and the global economy sank. And so in the beginning they were uninterested, and then they become very interested because they really needed the work. And so it kind of speaks to sometimes these evolutions and innovations that we've been part of are kind of happenstance. They're good timing, and they're sort of building on the shoulders of previous ideas. That's
that's our wood concrete composite floor. The HPV system are these perforated, or they're actually expanded mesh elements that you see there. the mechanical consultant, the mechanical contractor obviously didn't understand that these plates were structural, and they just cut through them and bent them, and they thought they were there to support the rebar.
So you get that. This is a massive mistake you're looking at here. Like, we had done all the structural prep work, and then they cut all the pieces because they'd never seen it before. And it, again,
they had to remove all the rebar, remove all the tubing, run it parallel to the connectors, redo it all over.
So these are the lessons learned, right? It hadn't occurred to us to make sure the mechanical contractor actually understood how the structure works, and it's a structure they'd never seen before. So since then, we've gotten very good at pre-construction conversations to make sure everybody understands what they're looking at.
Yeah, so there's a view of the prefab panels, which came out of the Structurecraft factory in 12-foot by 30-foot format.
And that's the finished space. And I'll just kind of say that we learned a lot about the difficulty of these diagonal screws that connect these wood panels. They would go into LSL, and instead of like in solid wood, you might just diagonally go in. We were finding that they would find the seams in all of that glue joints. It's very dense material, and they would start to bend and then snap off. So we were just breaking all these, $1 screws constantly. That's the early GRKs, and yeah, it was very, very interesting to learn how best to make and work with this material, and we were very grateful that CLT came along because it's a little bit easier to work with than LSL.
Okay, well, in the interest of time, I know we're almost at time, so hopefully everyone can stay a little longer, because we did want to have a little bit of a discussion at the end and just talk about some of the inspiration that these individuals are bringing to the next generation. So we're going to quickly go through the next couple projects very quickly, and leave some time for that.
Sure, very quickly. The Earth Sciences, which happened shortly after CERS and right next to it on campus. This is at a time when both Nordique and Structurlam were getting ready to produce CLT, but we knew they weren't going to be on time. So we decided to do the floors out of wood concrete composite. We had a very clear mandate to design a building that would perform as well acoustically and structurally as concrete. So that's what pushed us towards wood concrete composite using LSL. And we also had some very large transfer trusses over the atriums, which were wood concrete composite and steel concrete composite, with very efficient parallel to grain connections for the truss diagonals. But the really innovative element in the building is that cantilevered staircase, which Perkins and Will wanted to act as a meeting place for the different users in the building. It's a 12-foot wide, it's an oversized stair, and they really wanted it to be the innovative element of the project. So they challenged us to do a fully cantilevered stair, which is pretty easy to do in concrete or steel, but had never been done in timber. And we, of course, needed very rigid connections in the landing to run connections. So we use, again, the HSK system, which is a perforated plate, which is glued in, which gives us the rigidity we needed.
Nice.
Okay, I'm going to do this really quick. So the case for tall wood buildings is the outcome of a trip we took to Austria learning about CLT. One of the things that really resonated for me is that the way the Europeans were using CLT was not going to be viable here. And that's because here, light wood frame construction at low heights is very cost effective. And the work Shelley did around moving from 4 to 6 is a good example. It's very cost effective. So it was very clear that CLT needed to be, in order to be a viable material for us to use, we needed to find other purposes. And the origin story for me on this was sitting with my son when he was 6 years old and taking big plates and playing around with the idea of how you could balloon frame just by virtue of the size of the panels and create this sort of panel that would go 4 stories and suspend floors in between. And I took that to Eric and Robert at the time and said, hey, is anybody doing this or thinking about this? And we did a bit of research and realized no one was. And so that began this pursuit of tall. We started at 12 stories. I went to Japan, came back and said, Eric, we got to build as tall as the ancient temple, so let's go to 18. And then really quickly, because it is important to the story, is I was misquoted in Australia. I went to give a lecture, and in that misquote, somebody had asked me, the reporter had said, hey, how tall could these go? And I think, I don't even remember it, but I guess I said, well, I don't know, maybe 30 stories. And I had presented that Prince George Airport you already saw, and the reporter obviously wrote down Prince and didn't finish. And so I got on the airplane with my daughter from Australia flying home, and the front page of the Globe and Mail, our national newspaper, said, Canadian architect is building a 30-story tall wood building in Prince Rupert, which, if you're from BC, it's a tiny town. There's no tall buildings in this town. But that mistake really is a great example of how, you know, innovations come from good ideas. They also come from good opportunities. The two ways you could look at that moment is damage control, as some of the people around me looked at it, or the biggest opportunity of a lifetime, as I looked at it. And we dove in deep and developed this case for tall wood buildings, which out of two things, I'll say, giving it away. I wrote it and said, there's no IP, this is Creative Commons license, no one can own these ideas. And that single thing, the media later told me, is the reason they all wanted to talk about it. If I had said, this is mine, I own the intellectual property around the ideas in this, that's advertising. They would never have written about it. By giving it away for free, the media and the global media paid attention to it. And it speaks to the sort of mission statement of why we do the work we do. It's to make beautiful things and solve problems for clients, but it's also to change the world and make it a better place. We all know that wood is the right material from a climate point of view, and the mission of Tall Wood was to bring wood into more buildings and expand the possibilities. That's it. And I think that lesson led to me getting on stage at TED, which was honestly the scariest thing I've ever done. And I'm a pretty serious ice climber, which is also a very scary sport, but this was the most terrifying thing. But as a result of this, this did end up in 30 different languages and a couple million views worldwide so far. I don't even know, 2.5 million now. And it helped us get to the place internationally on tall wood that we have. And so I've always been really grateful for TED to help us spread this idea. But these ideas began with this group of people and the character of building on each other's shoulders. Not only here, we've also heard of those around the world. I was informed by those in Japan, those in Austria and elsewhere, and I think it's really important to remember that's what we're part of, is helping each other get better, and that's what led to this.
So, and maybe this we can do the...
I'll do it in 1 minute, seconds. 30 seconds, ready? This was our first tall wood building in North America and the second in the world after Andrew Waugh built Murray Grove. It's not very tall. It's in Prince George. It's all wood. It does have a really, just jump to the section. It has a cool section I like that I still want to do again and I haven't done again. Just keep going there. No concrete, entirely wood, including the fire stairs. We did a lamination of 5-ply and then 3-ply on top, 5-ply and 3-ply like you see here, which allowed us to completely integrate the whole thing into about 250 millimeters and give us an accessible ceiling and accessible floor. I think these ideas are still really important for the future of how we build some of these buildings, and so that's what we learned there.
Yeah, and so we'll end there, and for those who can stay around, we're gonna have a bit of a conversation just about some of the kind of thinking and design philosophy. So if the rest of the panelists could come back up to the stage, and we'll have, for those who can stay, of course, if you have to leave, no problem, but I don't think there's anything here after us, so we'll just have a quick conversation about some of the thinking and kind of way each of these people approached design problems, which led to these innovations that we see here. I think there's a lot of interesting, obviously some of the amazing things we had here in BC with timber, but also just the way that each of you approached design, which led to taking risks or going beyond maybe what had been done before. And so I'm just gonna open it up to all of you to answer and kind of give some of your inspiration, but then also if anyone has questions, we do have a mic and would love to take a few questions before we close. So first off, anybody wanna talk through design philosophy?
I Well, I'm always happy to speak. As I said, I think the idea that we build on the shoulders of each other, and I know that for me, the work of the pack houses, John's not here up here anymore, it was very instrumental when I came here, just the elegance and the beauty of the work. And then the incredible reality is that I think in British Columbia, we have a group of 4 or 5, maybe more, of the best wood engineering firms you could have in the world. There are great engineers all over the world, but we are very fortunate to have partnerships as architects that brings the ideas you've heard today come together. And I think that has been part of the specialness of the work that's come out of this region and has allowed us to kind of spread as a center of excellence in the world. And there are many centers of excellence that we share with, but I think from a philosophy point of view, that philosophy of really respecting, listening, and collaborating with an engineer in all engineering, but especially structural, has made, certainly for me, the work we do more exciting, more interesting, and more productive.
We should get some questions.
Yeah. Any questions from the audience? And if you do have a question, please just raise your hand. There is a mic, or we might be able to hear you. Just shout it out. None?
None. There's silence. There we go.
Hey, thanks. I was at a meeting where we invited architects and engineers up to Partnership Species office, and it was a terribly crowded room with a lot of people, and no one knew what was going to happen. And I remember at the meeting, because there's many different voices, I remember yours, Michael, because you said, I'd rather not have this project, but rather have every Walmart to be out of wood. And it was really interesting because there's a lot of people that do artistic work, from the projects up there, from Lubor to Bing to Peter, Paul, everybody, Peter Busby, like the whole crew of up here. But the expression of how it's come across is how far can it be propagated around the world, and maybe just a dialogue, because expression is one thing, and consistency of delivering quality craftspersonship, I'll say, is I think you've done it where you've been restrained to keep it carry far, and a lot of people have expressive architecture like the pictures on the screen. And it's a balance, right? Like, you need that, but that is a real question I find, is like the expressiveness, because you spoke about that. I heard a lot from the engineers speaking about expression and expressive, which is great to hear from Jerry and Paul and the crews. But just talk, that would be great to hear from the panel, like how you get there and how do you see it moving forward, because there is expression, but there is how far can we get it to go, and that's, I think, more important.
I can say something. Go ahead.
Well, I think what we've seen here today is that the big opportunities for expression are in the structural. that if you start early enough and it's an integrated process. I mean, in the old days, it was kind of an architect would do the magic sketch and then say, "Here, consultant team, take this away and make it happen." And right, I mean, and you heard about code consultants being part of the mix. The code consultants can actually have an impact on driving these things forward, right? So it's. For me, it's about curiosity. We're very lucky, and you touched on it, Michael, and that we, in British Columbia, because of the forest industry, politicians got involved, right, and started changing policy, and building codes adapted, and UBC did 18 stories, and these were, and we don't, until you get out from British Columbia, you don't realize how radical some of the things are that are going on here, and it's really rewarding. And I think the Walmart piece, a lot of what you see trickles into those kind of projects, right? They become mainstream because they've been tested and somebody took the risk and moved it forward.
Can I step in for a sec,
Sure,
Lucas? Being involved in the increasing demand for wood products, the change from 4 to 6, was really interesting because it wasn't about monumental building. It was about the context. It was about, and it was really in a response at that time to Olympic Village, which was this new fabulous neighborhood. It is a fabulous neighborhood. It's 100% concrete. And it was like looking at that and looking at it from a local sustainable perspective. It's what do we do? What do we have here? And it was really that triggered how do we build context, and really looking at the 6-story model, and then really understanding through huge support from government, from NRCan, from the Canadian Wood Council, from Woodworks here locally to really help just increase the knowledge base and look at different ways, and looking at, as we move forward, what is the place for lightwood frame? What is the place for mass timber? And if you can build economically and build sustainably, how do you use less? And so how do you start to build well in a up to 6 stories in a lightwood frame is a really a key decision-making point, and understanding that there will always be a place for these extraordinarily beautiful buildings, but we also have to make room for 95% of the buildings that are built, and really start to make room at a neighborhood context and at kind of a low rise, connecting people to nature, connecting people to grade. And it's been really interesting. I've also been just recently left the Canadian Wood Council as a board member for years. But the mid-rise, this shift has resulted in a profound change in market share from moving up to 6 stories in construction, moving it predominantly in BC as a leader to probably about 85% wood construction from zero, however many years ago. And this alone has really re-galvanized much of the forest industry. And now I can get on my little soapbox, but as we're sitting now and as we're facing tariffs, trying to look at local build solutions, trying to look at how can we self-support, how can we work together as a team to really look at innovation, both for spectacular, beautiful central city buildings, and how do we innovate and how do we take this further and higher, and to allow mass timber, allow taller wood to build and really wring maximum benefit out of our local resources. And that's what sustainability means to me.
If I can just add, so the Walmart, thanks for remembering that. I'm not a fan of designing for the 1%. I think architects need to design for 100%, and I think the reality of where people spend time is where we should be spending our energy, and that is in grocery stores and Walmarts and not art galleries necessarily. I love art galleries, I'm not knocking them, but let's spend money where people live, and then inspire people, but more importantly, remember why we're here, which is, everybody's here for a different reason, but for me, I'm here because the world is on the edge of a incredibly existential threat from climate change, and we have to change everything about what we do when it comes to building, and that's not just here in Canada, that's everywhere, and our job, everyone in the room internationally, is to spread that word and shift the entire global way we build and think, and generating new products beyond forest products in the future that are even more sustainable is what we should invest in. And so I think we have to contextualize that we do that because we learn the technical skills, as you've all heard today, but we do that with a mission to do more with it, to inform a completely different way that the world can live and experience not just wood, but a much healthier relationship with nature and climate.
Great. Well, thank you, everybody. I know we're past time, so I think we're going to close it there. And of course, if you have questions of any of these panelists, then please come up and chat afterwards. But thank you. I'll put your hands together for some amazing contributors to the built environment here.